Okay, so I think we're live. Yeah, great. Okay, so good afternoon, everyone. My name is Alex Housley. I'm founder and CEO at Seldon. It's a pleasure to be with you here virtually. Thanks to Errol from H&M for inviting us along. Obviously, I'd much rather be with you in Stockholm, so maybe next year. So what is Seldon? We're a commercial open source company based in London. We're focused on building MLOPS tools and infrastructure to help organizations to accelerate the adoption of AI in the enterprise. Our software has been deployed, has deployed over 1 million models and is in use across over 12,000 active Kubernetes clusters globally. We've got customers include leaders in healthcare, finance, automotive, and retail. We're very proud to be working with Errol and his team. And in this talk, I'm going to give you a high-level overview of some of the important considerations for running machine learning in production. So to set the scene, really, the world is becoming really dependent on machine learning across industries and across geographies, from drug discovery to crop yields to fraud detection. But the dynamic nature of machine learning models trained on large data sets with live inputs means that models often don't behave as intended, or even worse, can reinforce existing biases and present new security or privacy challenges. As the world moves out of the R&D stage and into production, into real-world deployments, the success of machine learning will ultimately be determined by whether the models can have a net positive impact, not just on your business, but on society as a whole. AI is now been readily adopted across organizations. About a quarter of enterprises are now in this kind of mature stage of running models at scale in production. And about another 35% are currently evaluating different options. This is from a recent O'Reilly survey on enterprise machine learning and the AI adoption in the enterprise. This is split across industries and geographies. So financial services has, for example, a lot more adoption than, say, education or public sector. The investors at Andreessen Horowitz also recently released a survey which looks at the number of models that are in production. Clearly large enterprises are doing a lot better at this stage, having invested a lot more with higher value use cases, with now over 50% having over 30 models running in production. So really, organizations are moving up the stage through the stages of the MLOps maturity model. So this is defined in this case by GigaOM, and there are different variations of this. But we think a lot of the organizations that we're seeing, and I guess here today, will be moving from kind of level 2 to level 3 in this model. So you will have actually had some successful data science projects. You've proven the value. They're running in production, but you've not yet considered how can you scale that with continuous integration, enable better reproducibility, ensure that there are ethical standards throughout, including explainability and monitoring. We're going to dive into what is required to make this happen. First, it's good to consider that the running machine learning in production is not just a data science problem. It also requires DevOps, and these two teams need to work together. In the real world, they're often siloed, but obviously we're mostly working remotely these days. And they use a different suite of tools and have different backgrounds in engineering and mathematics. So it can take anything from a week to 6 months to deploy a model. And clearly you want to be on the closer side to a week than 6 months. There's a role emerging, which is ML engineer, which really kind of spans both disciplines. And at Seldon, what we're doing is effectively helping the people in the DevOps and the data science teams to augment their skill set so they can function a lot more like these very rare ML engineers who add so much value to organizations. So to sort of dive in a bit further on this, the machine learning lifecycle from end to end sees different stakeholders involved along the way, from data engineers in the early stages of data collection, data prep, data labeling, through to data scientists actually doing the R&D and building the model. And they often then hand over to those ML engineers. And once the model is up and running in production, we'll hand over to the DevOps team. There's product managers and general management involved along the entire journey. And it's important that they have a good understanding of what's going on along the way. Also, throughout, there's more and more metadata being generated throughout this life cycle. And it's important as you get into the production stage that the data scientists actually get a good feedback loop so they can understand how their models are running in production so they can continue to iterate and improve. So you can think of it as in the early stages all the way up to deployment as kind of a day zero problem. This is kind of a DevOps bit of terminology. And at the point of actually productionizing, you're in day one. And but then there's an ongoing effort from that point onwards to keep those models running in production. So you can think that the life cycle of machine learning model kind of really only begins fully in terms of the amount of effort once it's actually running in production. So we believe that it's important in this process to give data scientists more freedom as well, so that they can continue to iterate without compromising compliance or governance. And so this is really what we're focusing on at Seldon. It's this final last mile of putting models into production and realizing their true value. So how is MLOps kind of adopted across the organization? First, typically you find it's a project which kicks off at a team level. And this can be pretty agile because you have fewer stakeholders to involve, smaller amounts of training systems, and smaller number of models. We see about 50 models as sort of the max at this level. And then business units at this stage, you've got to consider there might be multiple different training systems and different frameworks in use, and existing DevOps team and processes, further kind of department level requirements, constraints, permissioning. And then when you move on to the org level, the sky's the limit as far as the number of models, number of users. At this level, there's likely to be different, not just platforms, but clouds, hybrid clouds, and kind of high level like compliance and organizational principles, hopefully principles also relating to AI ethics as the industry matures. So we'll be looking at these sort of 4 challenges around orchestration, monitoring, explainability, and governance. And through this, we'll be covering some of the underlying architectural patterns. I won't go into so much detail on each of these. This is meant to be kind of a high-level talk. But what these enable you to do is to really efficiently scale across hundreds or thousands of models in production. So to kick off with orchestration, really, the quickest way you can get a model into production might be to wrap it in Flask, effectively a lightweight server, which is all well and good and it works well until the point where you actually need to be running multiple models in production from different optimized model servers, say TensorFlow plus PyTorch, that you need to have good metrics and traceability and lineage, etc. So if you have no sort of lineage or auditability or monitoring, it will eventually slow your organization down. And so putting the tools in place to enable a more scaled up deployment of machine learning models requires more complex architecture. And what we've seen is Kubernetes from the very early days of our development has been sort of an ideal kind of platform for building both the infrastructure, but also packaging up and deploying containers. And in doing so, we see that as the requirements extend, we can kind of abstract away some of the complexities of some of this deployment architecture into standardized components. So at Seldon, what we've built is this concept of an inference graph. And what that enables you to do is to not just deploy a single model. So you see the top diagram here, you have just model A being served effectively through a microservice. What this inference graph enables you to do is to package up multiple different models and to create a graph which includes other components, some of which that we provide at Seldon, but it's also an open architecture which can include custom components that you've built yourself, for example, a custom transformer. So this inference graph is declarative, can be defined as a Kubernetes custom resource, and then put in and managed in production. So being able to then deploy models, I suppose there's many different popular frameworks, and every year there's new trends. So it's important that your ML system is flexible enough to work with the latest frameworks, and that your data science team can use a variety of different frameworks out of the box. So we have enabled the different frameworks to connect into the inference graph via their optimized model servers. But it's also possible to create your own custom model servers using source to image. And we have documentation which shows you how to do this. On the right here, you see a screenshot of the kind of deployment creation wizard in our enterprise product, Seldon Deploy, but also all of this can be configured manually using config files within Seldon Core. And so these models would eventually live in a centralized repo such as S3. So moving out from this kind of more advanced serving system into like a broader MLOPS infrastructure, there are various different subsystems that come into play, data stores and repos. The first, if you look at the pink box here, the data scientists are using their preferred environment for model building and experimentation. This could be leveraging open source frameworks or commercial products. And the outputs of this are going into an artifact store such as S3. Secondly, you want to manage the workflow, leveraging continuous integration or ETL pipelines. Third, we want to manage the rollout of those models into production. So configuring things like resources and auto scaling. It's important that everything in this environment is auditable and reproducible. We're not just, we're working with, for this metadata store, which we've integrated into the latest release of Seldon Deploy. And Seldon Deploy is also backed by GitOps. So each and every update to the models in production is effectively a new commit into the Git repo, which makes it really easy to reproduce and to roll back where you want. So this provides a fully kind of declarative infrastructure, pushing out the models into production on one or more Kubernetes clusters, as well as a development environment. So there's also the concept of Canary Tests. So when you have a model that maybe built using any of these different popular frameworks, it will be served, say, 100% of traffic. You set up your auto scaling, and a few weeks later, you realize that you want to deploy Onyx. So this new model, rather than pushing it out to 100% of the traffic, you can push it out to a small percentage, 10% in this case, to see how it functions before committing to a full rollout. If you wanted to, you can always revert, or you can promote that model to 100% of the traffic. So you can enable this rolling update with zero downtime to minimize risks. And if you wanted to revert back to your original, of course, you can do that. So this is fully integrated into what we've been building at Seldon, and we see as a really essential part of actually managing the deployment of ML in production. So moving on to monitoring at scale. So really, like, the purpose of monitoring in any context is to make organization more proactive rather than reactive. Many of you will have experienced application monitoring, focusing on things like tracking errors and service availability. For the uninitiated, it sounds quite similar. But as we've been focusing more on this problem at Seldon, we really understand that this is an order of magnitude greater in terms of complexity, due to the nature of machine learning, where the model is effectively the application, with the live data, the data effectively influencing the model, and the unpredictability sometimes of the output. So first, we'll talk about service metrics, which is kind of the more standard thing you'd see around monitoring the resources, understanding the request per second, the latency. This is crucial for managing your compute costs, as well as understanding and tracking the response times associated with SLAs, both internal and external. Secondly, there's statistical monitoring. So you actually not just want to understand the performance of the system, but actually the impact on business KPIs. One of the things that we've integrated into Seldon Core and is available via the monitoring dashboards is the concept of custom metrics, which you can use to extend the metrics server to integrate your own business KPIs. So you can monitor those, understand how they are tracking as the ML is running in production. And then there's outliers. So effectively detecting and tracking anomalies and flagging and alerting, because these anomalies, if they're acted upon automatically, can have a very negative impact on the business. The outliers, but when you spot an outlier, it basically enables you to see where you want to focus the attention. Because if you have a data science team and DevOps team who are looking at how we can optimize the performance of a system, often the outliers will be an area to look at to see where there may be kind of holes in the data or issues in the underlying training system that need to be need to be looked at. Obviously, depending on the use case, it will dictate how you will react to different outliers and upon which thresholds. You may want to put a human in the loop, for example, or an additional sort of validation step, manual validation step. So so this is crucial. And then there's drift. So over time, when you train machine learning models, the data that is used can go out of sync with the data that's actually running through a live system. So this example you see on the top right here, shows a number of different kind of image classification data sets. And in it, these are all bananas, but actually they all look a lot different. So if you were to train a model on one of these and then try to use it to predict, classify on another set, image set, then the output will not be as accurate as you would hope. And so this goes beyond the kind of academic examples. In the case you see in the bottom right here, is showing you the samples taken of cancerous cells. If this was taken in one hospital, but the model was then used in other hospitals, it could be something as simple as the dye that was used to create the image being slightly different, that could throw the model off and lead to inaccuracies in the outputs. So really the goal is to observe the model as it's running in production to determine if there's drift, and then enable the data science team to either retrain the model or to look at how they can maybe transition into a different model if this is not working. So we usually talk about concept drift, which is kind of the example here. But what we see most often is what we call covariate drift, because in that case, the actual labels are not available. So it's more of a kind of unsupervised process. So one of the challenges of online drift detection is the the data is arriving in real time in sequence, and you need to detect the drift as soon as possible. And the earlier you can detect it, this will enable you to actually act upon this drift and actually improve the performance and reduce the costs. So there's various different strategies that we are working on to detect this. And actually, one of the big challenges is understanding, is this just a natural fluctuation in the data? In this example, the probability distribution, it gets to a certain point where you realize that this is maybe not an expected sort of variance, but one that is actually an indication of the model drifting. So there's some complex strategies that go into that. We'd be very happy to discuss it further with you. So moving on to explainability. So machine learning models, as I'm sure you know, are trained using vast amounts of data, pushed through an algorithm, and effectively the logic that's created in the internals of the model isn't interpretable for humans. And there is a trade-off here between interpretability and performance. So you could create handcrafted rules, but these will not be as performant as, for example, say a multi-layered deep neural network. So in order to actually enable these machine learning models to run in production, these more high performance models to run in production, it's important to figure out a system for explaining them. And by doing this, we can build trust in the outputs of these models and deliver insights to data scientists. I mean, wouldn't it be frustrating if after this long process of building a new model which can revolutionize a business, that you couldn't actually deploy it? And we've seen this the case across many industries. About 40% CEOs, according to Gartner, have believed that AI will have a material impact on the business. But in the finance sector, from the survey in 2018, most of those respondents, over 60%, had the sort of fear of the unknown around the inability to understand the AI and the related risks associated with that to business reputation, meeting regulatory requirements. So there's different types of explanations that will be required, and this is whether it's a local explanation that's actually looking at a single output, or a global explanation to see what's happening across the model as a whole, whether it is indeed a black box or whether you have access to the internals of the model. And there's different types of tasks, as you know, from classification, regression, different data types, and insights. When you look at the insights, there are different algorithms that we've been working on. So I'll just showcase a couple of these. So one of them, very popular, anchors, which is effectively feature attribution to show exactly which features within the model, if they remain in place, will enable that prediction to hold. So in this cute cat picture, as long as this face area is shown on the image, it will classify as this cat. And another example, counterfactuals, we're looking at how can we determine what you'd need to change in order to get to a desired outcome. And what's the minimal amount of change that would be required. So you can see the slight variation between the 6 and the 5 here, or in the other case here of detecting the income, just changing the education has impacted this. So this could have some use in bias detection as well. Another classic example is to say, why was this loan declined? What could be done to make it accepted? So, there's a vast array of research or different algorithms happening in this area. And what we've been doing at Seldon is, looking at what's the very best available research and how can we push that forwards as well. We've produced a library, Alibi Explain, which really implements these algorithms in a way that they can actually be running at scale in production. We've made it really easy to understand, like, in which cases you may want to use these, and these all integrate very neatly into the inference graph concept I shared earlier. So these are well tested and proven, and Building these in-house would have a huge R&D overhead. We've really gone the extra mile to ensure that these are fit for production. But remember, obviously, it's not one size fits all. There's no silver bullet. So there's still an element of experimentation to see which algorithms will work best for you. So it's just a simple case here of integrating the algorithm within, I suppose, importing it into your Python project. And there's a very simple API you can use to integrate it within your application, and also then into your live serving system, whether that's Seldon Core plus Deploy, and KF Serving, which is part of Kubeflow, that we're also co-creators of. The explanations will typically live side by, the actual explainer would live side by side with the deployed model or inference graph. What we typically see the use cases with the monitoring system. You might see, for example, some output that you want to take a closer look at, and having an explanation system that's connected into that monitoring system allows you to dive in and provide and look at the explanation. So we've been really working to provide that really tight integration between explainers and auditing. So really, the monitoring and explanations really goes hand in hand. So to just give a very brief kind of overview of a case study with one of our customers, Covia Insurance, they created these critical production machine learning models, but it was actually the interpretability of these to justify these algorithmic decisions which prevented them from running in production. Through integrating Seldon Deploy with the explanations, they're able to actually integrate these key use cases relating to claims automation, payments processing, so they can actually have a real impact on their business. So finally, to move on to governance at scale. So obviously AI, the rapid global adoption of machine learning over the last years has caught the attention of governments around the world who have been developing policies around the responsible and fair use of machine learning, and this is becoming a very big priority at national level, as you can see from this just short 2-year period, and I'm sure a lot more could be extended on this chart from then. Whilst there are a broad range of strategies and principles, what we're seeing is, regardless of that, there's kind of a very big overlap and consensus across the different principles and priorities around what the priorities are. It's very important then, like the principles are mapping to the policies, and then the policies are mapping to your infrastructure. So I'm sure many of you will have been discussing the recent EU AI regulation that were published in draft form recently, this has a big emphasis on trustworthy AI and categorizing risk. So, for example, high-risk use cases will need regulating, and others will be prohibited entirely. So, whilst this is early days, this is a very high priority, and it's likely that it will take 2 years. That time frame is our estimate of when this will actually become law. And you can expect for the high-risk use cases, systems would need to be installed 6 months prior to that. And the big focus here is on end-to-end systems. So even if you take components from different vendors, once that is integrated into a full AI stack that is delivering an output, then this is where this comes into play. Another key requirement is enabling the monitoring of AI systems in production to ensure there's that continued compliance with the regulations. So whilst it's going to take its time to run through the councils, I definitely start looking at what is in here now and start planning towards it. And I'm sure that as an output, we'll have a much healthier AI industry and usage across Europe and obviously the world. So how do we convert these rules, principles into and policies into code? It's obviously a very big challenge, given scaling machine learning in itself is a challenge And so this is what we've been looking at Seldon, and really is how do we convert these policies and principles into actual productionizable systems. The LFAI has, which is the Linux Foundation for AI, which is obviously part of a leading global software group. It's responsible for projects such as the Linux kernel and Kubernetes and Onyx, on the group level. Have put together this set of 8 principles for trusted AI. And this has been a collaboration between different very large organizations across the globe, from US, UK, China. And so I think that this has had a lot of thought that's been put into it. Actually, Alejandro Salcido, from our engineering director, was also part of the team putting this together. So what we've been doing at Seldon is kind of looking at how we can align between the kind of capabilities, the features that we're building in-house, and these principles. So there's a few examples on here, and I definitely encourage you to take the same kind of approach when speccing out your own MLOPS infrastructure. So to just dive into a couple of the points here, like reproducibility is something that we are enabling through GitOps, which I've described earlier. So the concept of being able to take your models, trained, integrate them into a centralized object store, and then enable the actual declarative sort of snapshots of those models and the infrastructure to be maintained within the Git repo. So you can always then roll back to the previous version and understand, have a full audit trail of everything that's happened. And this is what it looks like within Seldon deploy. So there's kind of, in this example, like a diff when between the previous deployment and the latest deployment, which will include some YAML. And then with as I said earlier in this there's a metadata, increasing amount of metadata being generated throughout the ML lifecycle, and it's important to kind of capture that and store it, both for internal data scientists who will want more visibility throughout their deployment and data science processes, understanding which models they should be using, not just referring to a simple, effectively file name, but the algorithm, the connected data, and then other variables. But it's also very useful from a sort of lineage and auditing perspective. So we've integrated this model catalog now into Seldon deploy, and we'd love to share it with the delegates at NDSML. So just to wrap up with a few final thoughts, the people here at this conference are practitioners that really are kind of leading the way just by being here and sort of building this sort of first phase of machine learning sort of infrastructure and use cases. And really, it's a responsibility of the people here to ensure that the things that we're doing, ultimately will be deployed in the most responsible way possible, and to have maximized the kind of the good outputs, and to minimize the risks of any sort of negative consequences. So whilst this is a very big challenge, starting from zero, we've seen and we've been part of this democratization of MLOps, including the monitoring and explainability. And there's a fantastic ecosystem that we've built upon as well, including cloud native tools. So encourage you to engage with this ecosystem. There's a lot more out there than what you may expect. And really, like, following this conference, encourage you to bring together your colleagues at your organization and your peers across the industry to talk about responsible AI and map these trusted AI principles onto your roadmap. So also encourage you to engage with the team at Seldon, to connect with us. We are one of the sponsors here. We're very easy to find via the sort of virtual conferencing facilities. Also encourage you to join our roundtable sessions, which we'll be tweeting out from Seldon.io. So if you want to learn more around the tools that we've been building here or would like a demo or a trial, please get in touch. We'd love to hear from you. So on that note, I will thank you. And if you have any questions, I'd be very happy to take these now. Thank you. Okay, it looks like I've gone a little bit over, so people may have left. But I hope that was useful. We are due to finish the session, 6 minutes ago. So I've gone a little bit over. But thank you, anyone that stuck with it. And we'll be sharing the slides and look forward to connecting with you in due course. Have a great rest of the conference. Thank you. Bye-bye.